Welcome to Arithmetic. I'm Yui. This video series assumes that you studied arithmetic and became at least somewhat proficient with it at some earlier time in your life, and now you need to either review it or relearn it. This particular video will introduce you to the most basic types of numbers, how numbers are written with decimal notation, and how to convert between numbers written with words and numbers written with digits. We're just going to dive right in without any hesitation. Be sure and do all the practice problems at the end of each video. There's a famous and simple saying in math education: math is not a spectator sport. In other words, if you want to learn math, then you need to do math. It's not enough to just watch and listen and read. So do your homework. Don't try and do it in your head. Write it down. I've worked with so many students who are pretty good at math, except that they were too impatient to write down all of their work. So then they would try to do most of it in their heads, then they would make a lot of tiny and easy mistakes, then they would lose a lot of points on homework and tests, and then some of them wouldn't pass the course. So don't just do your homework, write it down. And don't just scratch it down like you're trying to exorcise a demon from your body. Organize it. Number each problem. Put some space between each problem and the next. And when you're done with it, hang on to it. You might want to look at it again in the future in order to review. And you might want to do that weeks or months or maybe even years from now. So hang on to your homework. Finally, if you're in a math class with other students and you feel inadequate because one of them seems really smart and really on the ball and able to yap out the right answer like it's a bodily function, don't worry about them. Worry about yourself. Worry about your own learning. Don't worry about other students. So here we go. Let's start off with a basic classification of some numbers. The numbers 0, 1, 2, 3, 4, 5, and so on are called the natural numbers. The ... indicates that this list goes on forever. So the numbers 6, 7, 8, 9, 10, and so on are all in this same list, and they're all natural numbers. All of the natural numbers except for 0 are also called whole numbers. The numbers in this list are natural numbers. The numbers in this list are whole numbers. 0 is the only natural number that isn't a whole number. I need to point out that there is no agreement among different textbooks which numbers are called natural and which numbers are called whole. Some books say the exact opposite of everything I just said. But most professional mathematicians do use the name natural numbers to mean exactly what I mean. So that's the standard I'm going by. If you're in a class and your teacher uses different definitions than I do, then just go with what your teacher says. There's nothing I can do about that in these videos. You might also hear the name counting numbers. In these videos, counting number is just another name for natural number. It's a good name, though, because the natural numbers are all the numbers you can get by starting at 0 and then just counting up one at a time with your fingers. Let's look at some examples. 723 is a natural number. We can get to it by counting with our fingers. It'd take a while, but we could do it. I want you to hold on to that idea as what it means for a number to be natural. If it's natural, then we can count up to it with our fingers. 723 does not equal 0, so that implies this little symbol right here. This just means implies. It's called a blackboard bold arrow or a double struck arrow. But anyway, 723 does not equal 0, implies 723 is a whole number. What it takes for a number to be whole is that it's natural but not 0. Here's another example. 422.1 is not a natural number. It cannot be reached by counting with your fingers. And if it's not natural, that implies that it's not whole. So 422.1 is not a whole number. However, 422.0 is a natural number. Having just 0.0 on the end changes nothing. It's redundant. 422.0 is equal to 422. In fact, 422.00 also equals 422. And so does 422.000. So long as there are only zeros after the decimal point, you're dealing with a natural number. Furthermore, 422.0 does not equal 0. So that implies 422.0 is a whole number. All right, let's talk about place values. We write down and read numbers according to decimal notation. I want to warn you that this is another situation where different textbooks and different teachers might use a name other than decimal notation. They might say the decimal number system, or just the decimal system, or maybe even just decimal. They might also say the base 10 number system, or maybe even just base 10. If you're in a class, just go with what your teacher says, but I'm going to say decimal notation. So what do we mean by decimal notation? We write numbers with 10 digits, 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. It is certainly possible to take any one of these 10 digits, say 6, and read it as the number 6, meaning it indicates 6 stones or 6 hours or 6 of whatever. But when we call these guys digits, all we really mean is these 10 symbols which we write down and read. We say things like 49 is a 2-digit number, 4.92 is a 3-digit number, 1 to the left of the decimal point and 2 to the right. 97,230 is a 5-digit number. 1,723,422 is a 7-digit number, and so on and so on. But let's get back to the idea of writing numbers down with the 10 digits 0 through 9. Let's look at the number 23. We can write 23 as 20 plus 3. And we can take that 20 and write it as 2 times 10. So that means we've got 2 10s and 3 1s. The 23 that we started with is decimal notation for this information. We don't want to say 2 10s and 3 1s when we can say something simpler like 23. To finish this example, we say that the digit 2 is in the tens place and the digit 3 is in the ones place. Now let's look at 1,893. We can write this as 1,000 plus 800 plus 90 plus 3. Even though it's redundant, we can write 1,000 as 1 times 1,000. We can write 800 as 8 times 100. We can write 90 as 9 times 10. And then we'll just carry along the 3. So now we've got 1,000s, 800s, 9 10s, and 3 1s. So the number we started with, 1,893, is decimal notation for all this information. The digit 1 is in the thousands place, the digit 8 is in the hundreds place, the digit 9 is in the tens place, and the digit 3 is in the ones place. All right, let's do one more of these. In the next example, we're going to skip what's in parentheses here. So let's look at 2,070,817. We can write this as 2 million plus 70,000 plus 800 plus 10 plus 7. 2 million can be written as 2 times 1 million. 70,000 is 7 times 10,000. 800 is 8 times 100. Even though it's redundant, 10 is 1 times 10. And then we'll carry the 7 along. The number we started with has 0 as a couple digits. We've more or less ignored those so far, but we won't ignore those when we list out what place value each digit has. To start off, the digit 2 is in the millions place. The digit 0 is in the hundred thousands place. The digit 7 is in the 10,000s place. The digit 0 is in the thousands place. The digit 8 is in the hundreds place. The digit 1 is in the tens place. The digit 7 is in the ones place. So you might have noticed that there are a lot of places in these examples. What are all the possible places? They can't all be named because there are infinitely many of them, but we can name the first several. The ones place, the tens, the hundreds, the thousands, the 10,000s, the 100,000s, the millions, the 10 millions, the 100 millions, the billions, the 10 billions, the 100 billions. The example number at the bottom is 106 billion with a B, 924 million with an M, 170,358. Note the pattern that recurs here. Ones, tens, hundreds, 1,000s, 10,000s, 100,000s, or in other words, ones, tens, hundreds, 1 millions, 10 millions, 100 millions, or in other words, ones, tens, hundreds, and so on and so on. Each of these slots is called a place value. Every single digit of every single number has its own unique place value. Notice that we have these sets of 3 consecutive place values. Some people call these sets periods. Some people call these groups. Some people call these cubes. And there are probably other names I haven't seen or heard. I'm going to call them groups. The first group is called the ones group. The next group is called the thousands group. Then there's the millions group with an M. Then there's the billions group with a B. After billions, there's trillions, quadrillions, quintillions, sextillions, septillions, octillions, nonillions, and decillions. We'll stop the list there. You don't really need to know these for this course, but many people don't know what comes after trillion or quadrillion, and now you do. Okay. Let's suppose we're given a number in digits and we want to write the number in words. Let's say we're given this number. We can see this number has a ones group and it has a thousands group. So this number in words should be something thousand followed by something else. Notice that the word ones is in parentheses. That means we don't want to write it down in the final answer. Now, how many thousands are there? 70. How many ones are there? 304. 70,304 is the answer. Don't put an S on the word thousand, don't put a comma anywhere, and don't put the word and anywhere. So this whole mess written out with words is called the word name, or even just the name of the number we started with. Let's look at another example. Let's take a look at this big boy. Let's identify what groups we have. We have the ones group, the thousands group, the millions with an M group, the billions with a B group. We can see right away that the thousands group is all zeros, so we won't need any words for that group. And what we want will be something billion, something million, and then something else. How many billions are there? 1. How many millions are there? 50. How many ones are there? 27. 1 billion, 50 million, 27 is the answer. That's the word name for the number we started with. Don't put an S after billion. Don't put an S after million. Don't use commas anywhere. Don't use the word and anywhere. Now let's talk about writing out the digits for a number given in words. Suppose we're given this word name of a number and we want to write the number with digits. We've got 45,900,976. If we add these three together, we get the number we want. How about this one? 100 billion. Make sure you've got the right number of zeros. 1,000. 10. Make sure that the numbers are lined up correctly. Their place values should be all lined up. Add them all up, and you get the number you want. That concludes this lesson, so now it's time for some practice problems. Each screen of problems is up for 5 seconds, so you'll have to pause the video to copy them down. If you have any questions, feel free to leave a comment. Also, I'm interested to hear your answers for number 7. Leave a comment on that as well. Thanks for watching.